Hello, everyone. Welcome to my session on accelerating ML prototyping. My name is Parul Gupta, and I'm a production engineer at Meta. I work for Python Language Foundation team, where we manage Python ecosystems within the company. For the longest time, I worked for interactive computing team, where we basically focused on Bento, which is an internal distribution of Jupyter notebooks. Outside of Meta, I like to paint and I dance. Before getting deeper into the ML prototyping tools and how we accelerate it, I wanted to take a step back and talk about basics of ML lifecycle. When I first started out, I thought that the ML cycle was linear. You collect the data, you train your model, you test it, then you deploy that fancy ML model that you just trained, and then you're done. You get the benefits of the model that you've just trained. Easy, right? Well, I was a noob. It was very soon that I realized that it's a cyclic model with a lot of iterations and back and forth between the steps. Here is an oversimplified version of what ML lifecycle looks like, where you have project scoping, data engineering, ML model development, deployment of that model development, monitoring and continual learning, and finally business analysis and insights. Notice that there are a lot of back and forth arrows in between these components. These indicate that there is a lot of revisions and iterations before you actually get a better, improved results. In this, the data engineering and ML model development is what is called ML prototyping. This phase is very core to the development of the ML model, and its effectiveness can really speed up to get the better results faster. The most commonly used ML prototyping tools is Jupyter notebooks and conda environments. Jupyter notebooks is open source, web-based interactive computing platform. Jupyter notebooks allows you to create and share documents which contain live code, equations, visualizations, and narrative text and images. It's used in both academia and industry alike. It can be seen mostly in data science and engineering, where you can basically use notebooks to massage your data, put it as an input for your ML modeling, develop data features, do scientific computations on top of it, and even visualize your data and derive insights from it. It is also used in ML modeling and testing. To prove a hypothesis, a scientist will basically have to create an experiment, code a hacky solution, iterate a lot of times to train and test the model, and finally see if it works or not. Jupyter notebooks are language agnostic, which means that it's not just Python that you can code, but you can actually code any other language, such as R, Hack, JavaScript, and other languages. It's also backend agnostic. It means that you can run your code anywhere, be it locally or on a remote server or even on a cluster of GPUs and CPUs. Then comes Conda. Conda is a popular package manager used for managing software environments and dependencies in data science and scientific community. It is developed as part of Anaconda distribution and includes Python as well as other languages for mostly scientific computations. Conda allows users to create virtual isolated systems which can install different versions of packages and you can use them without interfering with one another or with the base system environments. This makes it very easy for you to manage your dependencies and even avoid conflicts between different packages and versions. How we accelerated it. Over here, now I want to share some of the ideas that we at Meta explored and executed to make this ML prototyping tooling and the general ML prototyping much faster for our researchers and developers to deliver the products sooner than you would generally in an open source environment. First comes Bento. Bento is an internal distribution of Jupyter at Meta. It is optimized for Meta's needs to make it compatible with internal code bases and can be executed on different services within Meta. Have you ever come across a situation where you would want to rerun and visualize your data on a regular basis? maybe make reports or see if your model is going through a performance decay. Inspired by Papermill's approach, Bento introduced scheduled notebooks, which are run on any cadence, on any servers, in a privacy-aware manner with all the permissions intact for the user's ease. Another thing that we introduced was persistent sessions. Have you ever come across a situation where you're running some long code for a really long time and you lost internet? Or something simple as Wi-Fi got disconnected or your laptop went to sleep? You will lose all the long-running executions and you'll have to start all over again. We implemented persistent sessions and sophisticated notebook recovery for users to access data computations across different Jupyter sessions, across different servers. You can simply execute long-running cells in your notebooks and come back to your Jupyter session at a later point, and you'll essentially be resuming your session, not restarting your session. Another thing that actually made a big difference in ML prototyping was cross-platform debugging capabilities between VS Code at Meta and Bento. Here, one click on a Python file would actually push you into a debugging session or push you into a Bento notebook for you to iterate with all the dependencies that your code might need. Not only this, we even moved the whole notebook ecosystem within the VS Code at Meta to have this enabled in a single platform in itself. There's several other innovations that we made. I'm not going to go through all of them, but here's some of the list. I can talk later if anyone wants. Conda. Conda is a newer introduction to our developer tooling. We wanted to bring most of the open source experience internally in a controlled manner. This enables faster onboarding of the researchers onto the ML development cycle, lowers the learning curve that you may have when you first start out in the industry, and also makes the model delivery much faster. Our researchers, basically our users, can actually play with their GitHub projects much more freely in that aspect. You also need to understand that Meta is a large monorepo. It's essentially one version across all the projects that exist within the company. Conda, on the other hand of the spectrum, provides full version control of dependencies that a user can experiment with before marrying to one specific one. Conda at Meta is packaged into a portable virtual environment, which is accessible from anywhere within the Meta ecosystem. And finally, as we plug Conda environments for our specific ML use cases, we enable better telemetry, accountability, and tracking in terms of errors, package usages, and vulnerability checks to ensure that the researchers can work without worrying about any sort of breaches that may occur unknowingly. The last interesting idea that I wanted to put across today was the power of combining the two things that I just spoke. Conda as a kernel in the Jupyter notebooks. This is something that we're exploring right now, and we're trying to see if we want to have it or not in our system, but this can potentially bring the research and the production development that we have today much closer to one another. Thank you, everyone. I'm gonna post my slides on my LinkedIn channel, so in case you want to take a look at all the resources, go ahead. Thank you.